Okay, this is my attempt at making a solar power system for my mother-in-law. She bought a small little rural piece of property kind of up in the mountains outside of where I live, and is off the grid and wants an opportunity to power this thing, or wants a way to do it. And so what we came up with was a solar power system, and I recognize I'm probably going to get criticized for a lot of what I'm doing here. This is my first run at it, and I know a little bit about this stuff, but I'm relying on a lot of other YouTube videos to kind of help me along. But basically what we're doing here, and this is the piece of plywood I've got. She's got a small house. The whole house is wired for regular mains voltage. She's got a breaker panel on there, and then outlets and light fixtures and stuff like that. And then on the other side of her small lot, which it's only about 30 feet wide, her lot, she's got a small tool shed. And so I'm going to put this board, and I'm going to cut this board down once I fit all the devices onto it, but I'm going to cut this board down and I'm going to mount it in her shed, and her shed's going to kind of act as like a control room for her solar system. She bought a 4-panel, what is it, the brand? It's these guys. Is it Renogy, or let's see here. Yeah, Renogy. So she bought, they have a 4-panel kit with that controller. And then I kind of told her all the other parts and pieces to build with this idea that I have. But basically I'm going to have this. This is a transfer switch. I'm going to wire that. I'm going to knock this conduit out, and that's going to run from a pipe all the way to her house in an underground conduit. There's the panel cover for it over there. And then that's going to be fed by either this, which is going to run off of a tri-fuel generator that she has, which the generator is also going to be mounted in the shed. And so I've got this kit down here to outfit the exhaust so that the generator can be mounted indoors but still exhaust outside. So our generator will plug in here, and then also this 3,000 watt Pure Sign Wave Inverter I'm going to also hardwire into that transfer switch. And so one end of the transfer will be off the generator and the other will be off the inverter. And of course the inverter is going to hook up to some batteries that I'm going to have a little shelf built for up off the floor of her shed. And then this box right here is something that I'm coming up with. It's my mother-in-law, and she's getting old. She doesn't understand how a lot of this stuff works. And so I'm going to drill 2 holes in this, and I'm going to mount 2 momentary push buttons. In fact, they're right here. Sorry for the crappy video. She's got a green and a red. I've also got a small 110 volt AC LED. And then inside there, I'm going to put 2 relays. One relay is going to feed off of AC power from the generator. The generator is going to feed AC power into that relay. But it's also going to loop through the button first. And so the idea is when you hit the button and complete the circuit from the AC power, it's going to activate the relay. And then the one leg of the relay is actually going to also take AC power and activate its own coil. And so when that happens, this AC light, this is going to illuminate, and it's going to cause a second AC relay to toggle. And that relay is going to disconnect the solar charger from the batteries and connect the AC charger to the batteries. Now, I don't know if you can have both chargers going to the batteries at once. I'm sure they're going to be putting out various voltages and, you know, slight differences in what they're looking for a charge. And so it's like having 2 different car chargers on one battery by different brands rated at different power. I'm doing that so that the batteries are charged from AC, sorry, not AC, but from the generator when the generator is on. But the reason I'm wiring it that way is if her generator loses power, or if she shuts her generator down, because the AC that you initially kicked off with this button is lost, and it's now feeding itself with that relay, then that relay will automatically fail back to its resting state, taking this one with it, reconnecting the solar charger back to the bank of batteries that'll be down on the ground. So that's the idea behind there. It's just going to have 2 relays mounted to a DIN rail in there. And then this box right here, it's just a project enclosure. And I'm going to take a couple, and I'm waiting on one more, but I've got some different voltmeters that I'm going to cut into there. I've got some momentary buttons. And so what this will give her is the opportunity to press a button, and it'll read out the output voltage from the panels, the output voltage from the batteries or the battery voltage, and then it'll do the AC voltage as well going into the house. So this box I'm going to mount right here and make its terminations inside this box and use that enclosure. And so the inverter is really going to be kind of by itself. The only thing that's going to connect and disconnect it is the transfer switch. But I do also have a battery disconnect switch because I want to play it safe. I'm also needing a fuse. I want to make sure that the battery terminals are fused. She's getting 4 deep cycle or AGM batteries, and my mother-in-law doesn't have a lot of money. And so she's going to end up probably with some deep cycle marine batteries for that. There's the relays that I got too, the ice cubes for the box. And so she's going to, so we just want a way to safely disconnect that. But I've got every accessory that I need, I think. I've got all my electrical boxes. I've got some metal flex that I'm going to use to connect all the different AC components together. I've got piles of Romex. I've got parts galore over here besides the Christmas wrapping paper. I've got everything from crimp-on battery terminals, piles of direct burial cable, a bunch of battery cables, a way to make battery cables. We really did spare no expense on Amazon. So we'll see if this is going to work. I've also got some more parts here. You can see the solar panel boxes there. So anyway, that's going to be my project. And what I've spent the last few days doing is laying out the board so that everything is efficient where everything is going to be located in her tool shed. And so I put the devices that she needs to access within easy reach. The generator cord is going to go straight to the generator that's going to be off to the side. This will be mounted in the back left corner of her shed. Her shed is 16 on center for studs, and so I've got those studs being marked out. And then when I get all the components on here, screwed to the back of the board, then I'm going to cut the board with a saw just so that I don't need anything that I don't need, you know, taking into consideration the studs and stuff. I've already measured the height of her shed, so I know that the board bottom to top will fit. So this inverter, when all said and done, if this was her back wall, you can see the ground, it's going to be kind of down toward the ground a little bit in the shed. And so the transfer switch is going to be right here about stomach height. And then not the transfer switch rather, but the AC charge toggle switch. I don't even know what to call it. That's about chest height. And then up here a little bit will be the transfer switch. And so it should be easy. I mean, if she keeps her panels free of snow and she keeps them angled at the right degree, I'm going to make the solar rack for the panels out of Unistrut, and then having a way to adjust the angle for winter and summer of the panels. We're up in Idaho in the Pacific Northwest, and so they're going to be kind of at a little bit of an aggressive angle, I think, during the winter. But her property does face south, so she's going to have the best shot at sunlight from where the panels are going to be. All the wiring is going to be an underground PVC electrical conduit. I've got the one stick right over here on my wall of crap, but we're going to get a few more pieces of 3/4. We're going to have one of those the D-mark sort of drip deals that you see on the top of old houses where the wires come out the bottom to keep moisture and other things out. They're up there right now dealing with 5 feet of snow, so I got to make sure that everything is at a height that she can maintain, but still do my best to keep it out of a good nightfall of snow. And then that's it. The only problem I'm going to, I think, run into beyond what I've got here is the neutral being bonded with the ground. So that's it.